you so much for coming here today. You guys are about to be wowed. There's 5 young innovators. They are developing solutions for challenges that we face today. Next presenter, Nicolas Fedrigo. He is a grade 12 student from Saanich who is creating an innovative solution for spinal fusion treatments. Welcome, Nicolas, to the stage.
So about a year ago, my uncle fell off the ladder and sustained a spinal injury. So as you may know, spinal injuries are very serious, however they can be treated through a spinal fusion. This is where screws are placed above and below the affected vertebra in the spine and then are connected using metal supporting rods to stabilize it. However, before those screws can be placed, the surgeon has to create the holes with a large awl-like tool referred to as a pedicle probe, which he presses into the patient's spine. And because of that, and it's rudimentary and not being very accurate, we see nearly 1 in every 3 patients who undergo this surgery result in very poor outcomes such as life-threatening infections or even paralysis. So when I figured this statistic out and I knew my uncle had to undergo a surgery, I kind of looked into it further and looked at what I could do. So I decided to redesign that rudimentary tool, the Pedicle Probe, to provide tactile and visual feedback directly to the surgeon and prevent those complications from occurring. This is based on vertebrae and how there are 2 types of bone that it consists of, cortical bone and cancellous bone. Cortical bone surrounds the spinal cord as well as the exterior of the vertebrae, and that is what you want to avoid. So I achieved this through monitoring force with my redesigned probe, and this provides feedback directly to the surgeon with a LED and a sensor and a vibration motor. And you can actually see my prototype right next to you guys on that table. So I tested this on lamb vertebrae, which is about the closest thing I could get to humans without taking illegally sourced monkeys or something like that. And it's also extremely accurate and precise. Currently, the leading technology in this field is actually fluoroscopy assisted surgery, which is a high form of ionizing radiation. However, the breach rate is still as high as 23%, and it exposes large doses of ionizing radiation to the surgeon while also being very costly. While my approach costs less than $50 to manufacture. I conducted patent searches on what is currently out there, and I determined that my probe is completely unique in the sense of providing that feedback to the surgeon through force threshold values, and it is also unique in providing personalized surgeries directly to the patients, so that would allow those with osteoporosis to undergo the surgery, while they once could not because it's not a standard procedure, and the surgeons would actually just open them up and pour liquid cement over the fractures instead. Thank you for listening to me, and I hope to make spinal fusion safer for both the patient and the surgeon.
Great. Thank you so much for your presentation. With medical devices like this that are used, there are a lot of processes and rules that one has to get through, regulations one has to get through. And I'm just wondering if you've thought about how you might be able to actually take this and move it along so that it could actually be used in humans.
Definitely, yeah. So I spent the summer at York University studying tech entrepreneurship, and basically we were partnered with people in business, and we worked towards getting a foundation, learning what we need to do to develop our projects into actual products in the market. And yeah, I learned that there are a lot of hoops you have to jump through, except if you can argue that the device you're implementing is exactly the same as something that is currently on the market with an added feature, then you can kind of bypass a lot of the steps, and that is something that my probe does incorporate. And also, Youth Science Canada offered to help me bring this to market.
So just as follow-up, where are you at in terms of trying to bring it to market then?
So right now, I'm near the end development phase. That is a completely functional prototype, and also I'm at the stage of surveying surgeons and seeing if they would adopt it, and then York University and Youth Science Canada would cover patent fees and help me bring it to market with the initial steps.
Great. Did you have a question?
I just have a question. Very impressive. Sometimes with medical images, particularly if it's imaging or probing, there is sometimes an industrial application with the technology. As you've been exploring this, and if you're looking at, I'm not sure how you tested, what materials you tested to simulate bone, have you come across any potential industrial applications with a similar kind of technology?
Like aside from the medical field?
Yeah.
Yes. So I have looked into it, and I did determine that there is actually an application for this in checking if telephone poles are still need to be replaced because they eventually rot in the middle. So you could actually test to see in advance if the telephone pole is still safe and if it will need to be replaced based on this monitoring density of the probe.
Great, thank you.
Thank you.
Thank you very much.
Thank you.
Thank you, Nicholas. That's great.